Good day, students. Once again, we are back to continue with our lessons. As I said, angles are very broad, looking at plane geometry. So we keep looking at the various angles one after the other. Today, we are going to look at angles which are formed on parallel lines. Angles formed on parallel lines. That is what we're going to look at it today. Angles formed on parallel lines. But before that, we need to find out what a parallel lines are. What they are. They are two or more lines which do not meet at a point. So basically, parallel lines are two or more lines which do not meet at a point. So we can have an example such as this. We have line AB. We have another line CD. Remember that the intervals between several parallel lines are always the same. But the extension of angle line AB and line CD will never meet. And this is what we are going to look at it. Some angles that can be formed on this parallel line here. In order for an angle to be produced on a parallel line, then we need a special line which is known as the transversal line. And usually the transversal line cut across several parallel lines. So we can have a transversal line moving from this direction here, cutting across this parallel line here. This line here is what is known as the transversal. We term this line as the transversal line. Transversal line. They are lines that cut across two or more parallel lines. When the transversal line cuts across two or more parallel lines, we will have several angles which will be produced on this transversal line. So we can have angle A, we can have angle B, we can have angle C, we can have angle D. Equally, the parallel line CD can also produce several angles. So we can also have angle E, we can have angle F, angle J, angle H. So these are various angles which are produced as a result of the transversal cutting across the two parallel lines that we have here. When such angles are produced, we can easily identify angles such as A, vertically opposite angles. We can also have what is termed as alternating angles, or some people will say alternate angles. We can also have what is termed as the corresponding angles. And equally, D, we can also have the co-interior angles. Co-interior angles. So these are the angles which are produced as a result of the transversal cutting across two or more parallel lines here. So we have vertically opposite angles, we have alternating or alternate angles, we have corresponding angles, we have co-interior angles, and they are all produced as a result of the transversal cutting across the various parallel lines that we have here. Now let's identify what we meant by vertically opposite angles. With vertically opposite angles, we usually call them the X type of angles. The vertically opposite angles. Vertically opposite angles. We call them the S type of angles. They are produced from the symbol of X. So this is how we identify them. We have A at the top here is vertically opposite to A at the bottom here. Then we have Y at the side here, also vertically opposite to Y at the other side here. So this is how we identify the vertically opposite angles. And usually they are equal angles. So we term them as congruent. We do not calculate for them. We only identify them. Now let's link this symbol here to our transversal together with the parallel lines here and identify the vertically opposite angles. Now considering now this line AB and the transversal ending somewhere here, vertically opposite angle produced on AB here. Considering the symbol of X, we can have angle A is equal to angle C. We can also have angle B is equal to angle B. We don't calculate for them. We only state the reason. So if A is 40, then it means that C is also 40. The principle is vertically opposite angle because they are formed from the symbol of X. Now moving down to that is the line CD. The vertically opposite angle formed on CD here also. We can talk about angle E and J. Angle E and angle J. So, we also have angle E is equal to angle J. We also have angle F is equal to angle H. Vertically opposite angles. So, vertically opposite angles, we only identify them. We do not calculate for them. They are congruent angles. Alternating angles. Alternating angles. I want to clean this side. Let's observe it again. Vertically opposite angle for a while. Okay. Then we can clean this and also talk about our alternating angles. So alternate using the same diagram, alternate angles. Now with the alternate angles, we are saying that they are angles which are produced from the symbol of Z. We can have Z this way. Then the vertex of the Z here, which is A, alternate with the vertex of this Z here. We can also equally have Z turn this way. And we'll say the vertex of that is B here alternate with the vertex of that is B here. So alternate angles are also produced from the symbol of Z. Now linking these two, that is our parallel lines and the transversal, we could see that this is forming a symbol of Z. So to identify alternate angles from our diagram here, we can say that therefore angle D alternates with angle F. So angle D is equal to angle F. We can equally also say that angle C also alternates with angle E. So we have angle C is also equal to angle E. We don't calculate for them, we only identify them because they are congruent, they are equal. So if D is 30 degrees, F is also 30 degrees. If C is 25 degrees, then E is also 25 degrees. And this is how alternating angles are formed from the vertices of that is Z. Let's observe it for a while. Then we can also talk about corresponding angles. Corresponding angles. That's alternate angles from the vertices of Z, linking up to our transversal and the parallel lines that we have here. Okay. Then we move on to the corresponding angles. Corresponding angles. That is corresponding angles. Corresponding angles. Now with the corresponding angles, they are usually formed from the symbol of F. Or some will also say from the symbol of E. So how do we identify them? The top F here, which is angle A here, will correspond with the inner middle angle here, A. We can also have the top in here, which is Y, will also correspond with the outer out here, which is Y. Corresponding angles. Same applies to that is E also. If we are to use E, we only close this section here, then Y will correspond with the outer side here. Let's link up that is these to our transversal that we have here together with the parallel lines. Now this line here is the transversal line and these are the parallel lines. So when you extend them, you could see angles. So we can have angle B corresponding with angle F. So we say B correspond with F. B is equals to F. We can also say that C correspond with J. So C is also equal to J. We also have A corresponding with E. So we have A is equal to E. Then we can also have D corresponding with H. So D is also equal to H. These are the corresponding angles that we have. The corresponding angles on these transversal and the parallel lines here. Remember that once again, corresponding angles, we do not calculate for them. They are also congruent angles. So with vertically opposite angles, with alternating angles, with corresponding angles, we term them as congruent. They are congruent. They are congruent angles. They are congruent angles. And congruent angles simply means equal angles. We do not calculate for them. One angle leads to the same as the other angle. Please, are we okay with that? Let's observe it for a while, then we talk about the last angle formed on the parallel line. Okay, now let's look at the last one, the last angle. Now with the last angle is what is known as the co-interior. The co-interior angle. Co-interior angle. with co-interior angles, they are not congruent